Welcome everyone. Today we have a special seminar in honor of Professor Robert Cess, who was the first person to do studies in atmospheric sciences at Stony Brook University. He is retired now and lives in northeastern Connecticut, and he is not able to be with us for personal reasons. Robert Cess joined Stony Brook in the 1960s as an assistant professor, and he was in the Department of Mechanical Engineering because that was his area of research. And actually, to be more specific, he specialized in radiation transfer in gases. And by the time he was an assistant professor, he had already published a well-received textbook on that subject. But soon after coming here, he became interested in radiation transfer in the atmosphere of the Earth and the other planets, and he published several pioneering papers on the greenhouse effect and its feedbacks. And this attracted other people who were interested in atmospheric science and climate change to the Department of Mechanical Engineering. And so Bob Cess not only was a very accomplished scientist, he is still was an accomplished scientist, as is seen in this description here on the screen, but his personality was such that he attracted many people to the mechanical engineering department who worked with him and who stayed there. And in this way, a nucleus of atmospheric science was created, which then gradually grew and became the Institute for Terrestrial and Planetary Atmospheres. And in 1992, then the university transferred us to this side of campus, and we joined our colleagues in ocean sciences. And in this institution, which is now called School of Marine and Atmospheric Sciences, or SoMAS. So it would be accurate to say that Professor Cess actually founded atmospheric sciences on this campus, and it is now an important part and a flourishing part of this university. And so in recognition of his contribution, every year, every spring, we invite a distinguished atmospheric scientist to give a special lecture. And today we do have a very distinguished atmospheric scientist, and it's a great honor to receive him here. And I would like to say a few words about Professor Peter Webster, who's going to speak in a few minutes. So Professor Webster is a professor in the Earth and Atmospheric Science Department at Georgia Institute of Technology. But prior to this position, he held the same position. He was a professor of atmospheric sciences at University of Boulder in Colorado, at Pennsylvania State University, and at the Naval Postgraduate School in Monterey in California. And his accomplishments are so amazing that he has received many awards, for which I would mention a few of them. So he is a fellow of the American Association for the Advancement of Science, and he is also a fellow of the American Geophysical Union, and the fellow of the American Meteorological Society, and also a fellow of the Royal Meteorological Society. So he was given the Mason Gold Medal by the Royal Meteorological Society, and the Carl Gustav Rossby Medal, Gold Medal by the American Meteorological Society, and the Adrian Gill Gold Medal by the Royal Meteorological Society. In addition, he won the Jules Charney Award from the American AMS, from the American Meteorological Society, and the Senior Humboldt Research Award from the Humboldt Foundation, and many others. And with all this activity in his spare time, he is also currently the president of the Atmospheric Science section of AGU. And during his career, he has served in a very large number of community service positions of great prominence. He has been a chairman of several panels of the National Research Council and the National Academy of Sciences. He was the member of the White House Review Committee on Global Climate Change during the Clinton administration in the 1990s. And also he was the chairperson of US Toga Core panel. And the list is very long. The other notable thing I would point out is that I counted, and so 29 people have received PhD under his guidance, and 26 master's students. His first PhD student was William Lau, who is the division head of atmospheric sciences currently at NASA Goddard Space Flight Center. He is the author of 2 textbooks, one on thermodynamics of atmospheres and oceans, and the other book that is coming out on tropical meteorology and climate. So before we invite Professor Webster to present his lecture, also before I go there, I just want to point out something else which is very, very notable. So when you look through his very large number of research publications on tropical meteorology and dynamics of the atmosphere, I noticed that he's always aiming, even 30 years ago, to make forecasts, to predict weather. So even in the, like we all know that in the early 1990s or 1980s, the models were not very good, but his tendency was always to figure out how to forecast the monsoons or the weather. And so, and then he has developed this interest into something very, very useful that he will speak about, and that is to make weather information available ahead of time in parts of the world where meteorological services are not very advanced. And so this is a huge contribution, because we know, and I know, that hundreds or if not thousands of people perish every year because of flooding in many developing countries, and in addition to the vast economic damage. But before we bring him here, I would like the Associate Dean of SoMAS, Henry Gokunovich, to please come here and greet our guests. And also I would like the atmospheric science faculty to come here so that we can have a picture with Professor.
The plaque. It says Stony Brook University School of Marine and Atmospheric Sciences in recognition of his outstanding contributions to atmospheric sciences. This plaque is awarded to Dr. Peter Webster on the occasion of his presentation of the 11th Annual Robert D. Cess Distinguished Lecture. Thank you again.
Sure. Well, thank you very much for the invitation. It's great to be around for 2 reasons. One, I knew Bob Cess many, many years ago, and he was an inspiration to me, even though our fields were slightly different. But he was inspirational to a whole group of radiational scientists and to some great NASA programs, such as the Atmospheric Radiation Program. And it's good to see Marv, and good to see Hemi Kim, who was with my group for 3 months in the middle of her PhD career, then came back for 2 years or 3 years as a postdoc, and finished up here. And I must say, you're very fortunate, I think, to have her. Okay. So Bob Cess, as I say, is a gentleman. He had his 81st birthday, so I had a nice chat with him this morning, so that was very pleasant. But what I'm going to talk about today is about hazard prediction in the less developed world, and what works, what doesn't work, and how to fix it. That's a picture, by the way, of the Ganges facing the rising sun at dawn in Varanasi, if anybody's interested. So a lot of groups involved in this, from NGOs to our little CFAN to National Research, Eastern WF, Emory, World Bank, and from NSF. So you're going to find out that I'm a little schizophrenic because there are two things I do. And the other is, anybody wants to come and listen to some of my monsoon dynamics tomorrow, which is a little theoretical. That'll be tomorrow. But today, I'm going to talk about sustainability through hazard anticipation and mitigation. And we've come to the very firm belief that a society that learns to deal with the present natural hazards will be best equipped to adapt to and mitigate hazards encountered in a changing climate. And by the way, SHAZAM, it's an unfunded acronym, but I think a good one, is an onomatopoeia for rolling thunder. And maybe Marv will remember, that's, here we have Captain Marvel, this is Mary Marvel, Captain Marvel Jr. And SHAZAM was also something that Calvin and Calvin Hobbes used to say, but the owners of the copyright of Captain Marvel comics stopped them saying Shazam, which I thought was a great shame. Learn things in these seminars. So I'm going to talk a little bit about why bother. Why should an atmospheric scientist in Atlanta, Georgia, start thinking about issues in the developing world? And I'm going to talk a little bit about environmental hazards and poverty, prediction in the Valley of Death. Some of you who have been involved in the private sector will have heard about the Valley of Death. Probabilistic forecasting, targeted, and then I'll give you 4 examples, and then some ways ahead about how to span the Valley of Death. So why bother? So this is a chap I met on a bridge in Dakar. It was during a cold outbreak in the middle of winter, which Sondra and I were talking about earlier on, and he was on a bridge. And I look into his eyes even today, and I'm not quite sure what he sees in me, but I saw a fascinating person. But I sort of wonder, why we do this sort of outreach science. And I'm a very, very stubborn person, and I've been at this now for 10 to 12 years, and with a little bit of success and an enormous amount of failure. But so why do I bother? I think it's in our self-interest and our national interest. Poverty breeds discontent, and many people in the world have this attitude, I am born to suffer. And I don't think that if you have any knowledge at all, you should allow that to be an acceptable premise of life. It's the right thing to do. I think it promotes goodwill and self-reliance, and it's also a lot of fun with the science. It's just that picture once again yeah. So what is the Valley of Death? Valley of Death is where you have the developed world maybe, or industry, whatever it might be, and you have those in need. What the developing world needs is all types of things here: determination of risk, preparation, adaptation to mitigation of hazards, and so on. And over here, be it in the developing world, some institution, or be it us, we have developed all types of basic research. We have global forecasts, and the trouble is that most of these great ideas finish here, failure, 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 in the Valley of Death. So it's an interesting thing to me. I'm not a psychologist or not much of anything really, but I sort of wonder how indeed one finishes when you have such good ideas, and not just my ideas, many ideas, that they are not being implemented in the developing world. So the other thing too, one we must say, is it possible to make predictions? Is hazard prediction a reality? And how can we take extended predictions towards a practical utility and an actionable reality? Trouble is that to do a forecast extending along 2 or 3 days, you need, of course, a global model. And I'll talk later on about the inaccessibility of global model output to many parts of the developing world. So what we want to do is pick a time which of hazard anticipation, so there can be a mitigation or an adaptation. And I've always thought about it, if you're going to give a hazard warning, it has to be so the slowest entity or couple in a village has time to walk away from it. And that's the villager and his cow, or her cow. So you need about 7 days. And so there are many impediments to this. So let me tell you a little bit about the type of hazards. These are maps of the world where their environmental hazards and the number of people affected give you the size of the country. For example, this is India, Bangladesh, China, and these are a totality of people affected by flood mortality. One can see India, Bangladesh, Pakistan, and strangely Brazil are most affected. And we'll notice that most of these places are in the developing world. These are the number of floods which have been growing at a pace over the last 50 years, although one has to be a little careful with that statistic because it could well be that there are many, many more people being affected. So one has to gauge that. So drought mortality, that's an African problem. And when you look at storm mortality, again, these are tropical cyclones. This is India, this is Bangladesh, and this is, would you believe, the Bay of Bengal scaled down. If a tropical cyclone forms in the Bay of Bengal, it's going to hit a lot of people. 5% of the storms in the world each year, about 95% of the carnage occurs in Bangladesh. Malaria prevalence, and I won't have time to talk much about disease today. I'll just mention it in passing. But here's the tragic thing I think of: killed by war. I just throw that in because all of the increments we make towards smaller populations, the education of women and so on, and then war destroys all that and it's back to the square one. Just a tiny bit about tropical cyclones. This is just 20 years of tropical cyclones, and you can see a large number of tropical storms here, all hitting. This is one of the few places in the world where the statistics show an increase in intensity. And finally, just a quick thing about floods. This is a difficult diagram, but this is the flood probability of lasting greater than 10 days for the Ganges and for the, which is the dotted line, and the straight line is the Brahmaputra. This is from models, carefully selected models, and here we have the period of time. At the moment, you have about a 10% probability of having a 10-day flood in Bangladesh at the present time. This may go up to a 40% probability as time goes on. So what we want to do is arm people here with the capability to be able to handle hazards for what happens here. And just to give you one other thing too, this is, just the deadliest tropical cyclones. Sorry, it's out of context. You can see the Bay of Bengal here is almost all of the major tropical cyclones in the carnage. Now, I will argue that we can give 10-day forecasts of these. The Indian Meteorological Department gives 3-day forecasts. More on that later on. So there are two types of floods that you get: the slow rise floods in Bangladesh, 98, 2004, 2007, and great areas were inundated over India. This is just the Brahmaputra floods. Brahmaputra comes down here from the Himalayas, and this is the inundation occurring on a particular day. Now remember, there are 150 million people living here, therefore a very, very large number of them are under flood at the moment. So what do each of these problems have in common? Hazards occur in regions of high population, and poverty has, and poverty, and they have most deadly impact. I'll raise a question for you. When you look at the Sultan and I were talking about this earlier on, when you look at the Brahmaputra Delta, the Ganges Delta, the Indus Delta, the Yangtze-Kiang Delta, there's a common feature in each of those. It's the most fertile land in the world. It's also the poorest, more poor people. So why would that be? I'll come back to that in a few minutes. Hazards occur very quickly, so there's little time to allow planning mitigation. In the past, they just arrive, no forecast. And each hazard, flood, drought, disease, could be mitigated with environmental forecasts that reach a trained and responsive populace. And I'll show you two examples of where populace were trained. Now, this is you've probably heard of the Himalayan Tibetan region referred to as the third pole. And these are the great deltas that have occurred, this is color-coded with population. And so what you see are enormously fertile places with many, many people, and principally poor. This is the anticipation of of population over the next 50 years. We're here somewhere now at 6 billion, going up to about 8 billion. This is the more developed part of the world, the yellow curve. The less developed is going to is taking up the majority of this curve. So the thing is, not only are the countries that I'm talking about the most populated, they're the fastest growing as well. This is just to give you an idea. One example that we were talking about before is Pakistan, 1995, number 7, going up to number 3 in terms of population. They have a doubling time rate of about 25 years. And this is very troublesome. This is the growth rate I just mentioned a second ago, the population growth rate. The regions that we're talking about are all here. They're all in the 2% per year plus. Give you an idea, I gave a talk at a church a few weeks ago on population, which I didn't know anything about and perhaps still don't. But I thought I should put something biblical on there in Genesis and say, God blessed them and said to them, be fruitful and increase in number, blah, blah, blah. So my point is that humankind has been a little zealous following orders. But there's a very, very interesting aspect to this. The doubling time of the global population has been on about 30, 40 years forever. So when you think of global warming, no matter what you think of global warming, be it exaggerated, be it understated, whatever, it's a people problem. So one has not to forget that it's a people problem. Now, one other aspect is that high income equals low population growth, low income equals high population growth. And this was attended to by Malthus many, many years ago. And again, we're talking about these countries in this region through here. In fact, I came across for this talk I gave in the church something very, very interesting. That these are the countries earning less than $2 a day. And this is no information, but my guess is they're less than $2 a day. At the moment, a person works for a day in most of these countries, and for his or her day's labor will get about 15 to 20 pounds of rice for their family. 2,000 years, 4,000 years ago, a worker would earn about enough for 20 pounds of wheat. In Rome, a day's work would give you the same amount of grain. In medieval times, England, again, the populace got about 20 pounds of rice. So things have not changed. The amount of grain provided only for subsistence. There's no accumulation of wealth. This was attended to beautifully by the prophets of scarcity, Thomas Malthus. And I would argue that his idea was that there's no accumulation of wealth because everything goes into subsistence. And the way to subsist is to increase family size. And so the doubling times of the population, again, all these nations through here in the 25 to 30 year. So we have a lot of problems. So in terms of looking at climate and hazards, and one looks in the future, there are certain certainties, that's good English, certainties, continued mortality, destruction from current hazard levels, flood, drought, tropical cyclones. We know at least they're going to stay at the same level. Continued growth of population, decreased freshwater availability dominated by population growth. The IPCC models show an increase of monsoon rainfall, but it's completely dominated by the per capita freshwater decrease due to population. Possible, probable increased threat of tropical cyclones, increased monsoon rainfall, decrease in neighboring areas, stronger, more frequent floods, inundation of coastal areas. But the point is that we can sit back and say, okay, we know that we suspect that Bangladesh in the year 2090 is going to be a meter underwater, at least near the coast. And therefore we should just stand there and wait, do nothing. Or during the lifetime of a farmer, he's going to get 5 major floods. So why don't we try and do something about that now? Now, everything I'm going to talk about resides around risk management and SoMAS forecasts. And the diagram here talks about low cost, high cost, low probability, high probability, And out of this, you can determine your risk. For example, if you have something that's very high cost, the probability of occurrence will give you the same risk. And risk goes as probability times cost. But you can rewrite this cost function in many, many ways so that you can divide up the population. And this is the same probability, but now we have exposure to a hazard from some sector. We have vulnerability of the sectors of hazard type, and here we have resilience. Now this is very, very important because I mentioned before that I raised a question to you. Why is it that certain parts of the world have remained perpetually poor, given the fertility of soil and so on? And it comes down to this resilience factor. If you have continually unforecast hazards occurring, you lose everything. And you start over again every 5 years, every 10 years, every 50 years, it doesn't matter. So the important thing is to build resilience. And the only way you can build resilience is if you decrease the risk, which means that you reduce the cost function, which means that you anticipate a flood or a tropical cyclone and can do something about it. So I'm going to give you a couple of examples. My argument would be that resilience over the last few thousand years has been decreased or remains remarkably small. By the way, notice that it's in such a position that risk increases as resilience goes down, even for the same probability. So what we would like to do is increase resilience. Now, first, can risk of a hazard be determined? And what we want to do is use global forecasts to be able to do this. And this is the type of thing that you get from ECWF, all different types of products. You do some statistical rendering and you come out with a forecast. And I'll explain in a moment that that's the easy part. So I'll give you an example of Bangladesh. Here is the Bangladesh, this is the Ganges Delta, and here is the Brahmaputra Delta, and here is Bangladesh. And it's from here to here is about 5 meter difference in elevation. So it's very flat, contains large rivers, and I drew this picture here for two reasons. This is a chap just walking on the side of a road. It's this road here, as a matter of fact, but as far as you can see, it is flat. So if you live here and somebody tells you you're going to have a flood, the only way that you can get to any place of relief is on these roads, which are elevated. And they're man-made. They're about 10, 15 feet tall. And so he would have to get his cow all the way to here. And he needs many, many days to do that. Now, why is a cow important? It's worth about 3 or 4 years of labor to buy one. So these are very, very important things. These are some farmers. And by the way, the interesting thing about this chap, and I don't know if this is true, but very often poor people, when they lose everything in a flood, they have to borrow money from a moneylender, and sometimes it's, I will take in return for the next generation half your produce. So who knows if this is for the moneylender or for his family, his cauliflowers. So water as a resource, floating haystack for you, fallow field, fish pond, but then again we have water as a hazard, floods, drowning, and so on, and water as a hazard in terms of contamination. And this is the copepod, and this is disease spreading. I might add too that this is a water tube well, goes down into the aquifers. It's probably up to 5,000 times as much arsenic as we allow in the water. So what we have then is flooding in the treadmill of poverty. In India, each year, 6 million hectares are inundated, and 30 to 40 million people are impacted with no forecasts. So I'm very quickly going to go through this. So an example from the past. This is a picture I took on a village, a city hall, a little city, town hall. And it shows you what you're supposed to do if a storm surge is to come. Tie your children to a tree, hang onto something and float around, get your belongings and run. But we can do better than that. This is why resilience is reduced, because every piece of destruction has to be rebuilt each time. So what is a useful forecast? A useful forecast is one that allows the slowest group in society sufficient time to evacuate to higher ground. What is a successful forecast? It's one that's been communicated to a societal group that's been trained to understand the forecast and how to implement a disaster plan. So, back in 2002, for reasons that I tell you that somebody said we had just written papers on the Indian Ocean dipole and the physics of why there was this oscillation in the Indian Ocean. And I gave this talk in Bangkok, and there were a couple of guys from USAID. I said, oh, by the way, the 1998 floods could easily have been forecast. It was just due to the rise and fall of the Bay of Bengal, 30 centimeters difference. Now, it may have some contributing effect, but it wasn't the cause. But they were particularly impressed with my bravado saying this. And they said, could you forecast floods then? I said, hey, of course, it can't be very difficult. I mean, if you know all the water coming from here and here, and you know the sea level, it's a cinch. You know, you can do that with a little reservoir model. And so then we arrived in Dakar, and I said, well, where do I get the Indian data, river data? They said, oh, India doesn't give us any data. And I felt this cold trickle going down my spine, because I thought, how am I going to get out of this? They'd already given us some money. But it turned out that what we did was synthesize the river flow here in the Ganges and here in Brahmaputra. And we did that using ECWF data. We downscaled, we built a hydrology model, and we had these two parts here. We had flow data for 50 years, so we could calibrate the model. And so the interesting thing about this, though, is that doing all that is 10% of the effort. Communicating and disseminating is 90% of the effort. So in 2007, 2008, we were lucky enough to get some funding from CARE, and in each of these pink areas, the little yellow areas and the pink areas, they were our villages where we spent time educating and preparing plans and so on and so on. And so the idea was to give prior training and so on. But I have to tell you an interview I had with a man the very first time I went to Bangladesh. So here's a chap, and we said, we hope to provide you with seasonal forecasts to help you plan your agricultural activities. The farmer said, through an interpreter, that would be good, I think. I said, we may not always be right, but maybe 8 times out of 10. He thought after this, but I said, that's fine. He said, only God knows 100% what will happen. And he is not telling, and you are not God. Right now, we guess each year, which means we're right as often as we're wrong, and 10 times means I'm ahead. And I thought to myself, boy, if the US public understood probabilities as well as this guy. So here's what our forecast looked like. And this is the 2004 floods. It's our first operational one. And these black lines indicate the time of exceedance of the flood level at actually the northern part of Bangladesh. And you can see that the observed flow is the black line in retrospect, and the ensemble mean is white. And these are the ensembles which give us the probability. And we picked the 2 peaks, which is very nice. And then why do we bother about probability? We were making forecasts here for here. And so what you finish up with is some type of distribution, like from here. And it says that, well, if I'd only done the forecast twice, I would have maybe had a forecast here, meaning no floods, and here something like a biblical flood. So what one wants to be able to do is do this many, many times. Here we do it 51 times a day, and to come up with a probability. And we did it again in 2007. We did it each year, but I'll show you these in 2008. And then we worked with the farmers and with training ahead, that in the event of exceedance of 75% probability, they should harvest early, they should transplant, they should go to safe refuge, the roads for their cattle, water storage, and so on. These are pictures of them doing all these things. By the way, there are 7 cattle here, which is 10 years of work. And here's what the results were. And so we interviewed people afterwards and did a sort of a quasi-economic analysis, as much as a meteorologist can. And this is a guy, he's a priest, And here's what he says: we disseminate the flood forecast information and how to read the flood pillar or flags. We had a system of flags, how big, deep the floods are going to be. And to understand the risk during prayer time in my field, he used the forecast for harvesting crops and making decisions for seedlings and transportation, blah, blah. We also saved our household assets. So the people who adhere to the forecast, fisheries, they saved $130. Agriculture, $190, livestock, $500 per animal, and household, $270. Annual income in Bangladesh is $450 per year. If they hadn't saved that, they would have to start from scratch. This way, they can move on. They have something to build upon. So that is the whole idea of what we tried to do. So the idea is the bottom line there: timely warnings allow at least the maintenance of resilience, and hopefully it's steady growth. There's the successful forecast, 10 man years. The other problem, though, is that these forecasts require predictive data from global ensemble prediction models. And how can a country the size of Bangladesh with limited resources manage to get data from ECWF or NOAA? Well, they can't. In fact, I'm a little unpopular in Bangladesh because I arranged for them to receive regional data to run the models out to 10 days over a region, rainfall over the major deltas. And it managed to, from ECWF, and ECWF were very helpful, and it managed to swamp their bandwidth completely. And so that's the other problem. There's access to the data isn't enough. You have to be able to receive the data. We also did extended tropical cyclone forecasts, which we still do. We forecast not just the path of tropical cyclone, but also its genesis. I'll give you two examples here. This is, by the way, our dashboard, which we make for people to use. This is Nargis, the one that took out tens of thousands of people from forecasts which were 10 days in advance, very, very good, but were ignored by the now defunct military government. And this is the forecast 29th, number of days ahead. This is the swath. And this is actually in movie form. This is a different one. This is the Phelan, which occurred just a few weeks ago. And what one can see is forecasting very well the eventual path. So part of this was precipitation in Bhutan, this tiny area here. And they'd had a series of rainfall. They thought the rainfall traditional thought as the rainfall had come to end. And they, after event B, they harvested. They left all the crops in the field to dry. Phelan came along, and 30% of the crops were lost by rot. Now this is lead time here versus date. The blue curves are the observed rainfall, which are shown here. And this is, one can see that event B was forecast 8 days ahead. This is probability. And here we have Phelan, which had a 4 or 5 day lead time. Oops, sorry. And so this is useful. The forecast can exist, can be useful. Pakistan flood forecasts in 2010, 2011, and 2012. And again, got myself into some trouble about this. I'll just tell you about that in a moment. And this is in this valley, again, enormously fertile. And as Sultan was saying, you don't have to go far away from the main river streams to be quite dry. So here's what the country looks like. So we decided to build a model so that you could point to any particular place in Pakistan any time of the year, click on it, and it will give you a 10-day forecast, probability forecast. These are some of the highest mountains in the world. This is some of the flattest country in the world. So, so we published this paper, which was, this is what the observed rainfall, this is the forecast rainfall. You can see the elements of these things are there. Now, and so we published this paper where the floods, 2010 floods in Pakistan, predictable. And it was sort of a one-sentence paper. Yes, they were. But so it came out in GRL and it was put online, and all of a sudden I had people from Pakistan calling me, the press. Why didn't you let us know? And I said, well, because we weren't watching. Well, what about ECWF? Why didn't they tell us? I said, well, they were not watching. They're principally a European organization. I said, but, you know, we could build a scheme for you that would allow you to look yourselves. He said, is it true that ECWF was a Western plot to punish the people of Pakistan? And I said, no, it's not true, that's not true. And so I felt really good about that because I sort of put down this rather obnoxious journalism. And so I got a call from a friend of mine who worked for UNDP, and he was in the flood areas. And he said, oh, you've been in the news. I said, oh, isn't it great? I said, I really fixed things, that this guy was trying to say that we were withholding forecasts on purpose. He said, oh, that's what the newspaper article says. So but these are the forecasts for those three floods, in these three areas, 2010, 11, and 12. And you can see here, these are what we call our forest fire diagrams, lead time versus date, and you can see the background rainfall. Each one of these events was forecastable 7 to 10 days in advance at high probability. Here we have the same for the 2011, not so well for the 2012. And so these things can be built. I'll come by it reasonably later. And so this is what the models look like. We don't have time to go into that. They're rather complicated. We have inundation models so that any place in this region through here, you can work out what the depth. It's easy to do a forecast of flow down the Grand Canyon, which is constrained by walls. It's much more difficult when there are no walls. So what you want to do is be able to forecast the inundation on the floodplain. Now the physics of this are very interesting because it's like a shallow fluid, and the shallower the fluid, the more important friction is, and therefore water over here, even after the flow in the main channel gets less, it's going to take a long time to drain away. So we have this dashboard where this is an old version of it, and if anybody's interested, I'll send a new website where you can pop on any one of these places in this, and finish up with a 10-day flow forecast. And this is the not very attractive version of that, which shows at locations 1, 2, and 3 what the probability of warning, normal, or watch would be. So we did the same thing for the Uttarakhand floods in June 2013, just a little while ago. And they had horrendous floods here. Many thousands of people were killed. And again, just to show you, again in retrospect, because we were not looking for this, this is the probability of intense rainfall, more than 2 standard deviations greater than climatology, occurring in this region through here. That is the same thing. So one other thing we do is heat stress forecasting. And actually this is a success story because we didn't suggest that we would do it. We were asked to do this by the local Gujarat authorities in Ahmedabad, Gujarat. These are the mortality rates, by the way. It's a bit hard because the data hasn't been filtered properly, but each springtime you can see there are large deaths due to very hot conditions. And the worst thing is the most vulnerable people are the poorest people. And so it's a very forward-looking state. And they're trying to work out ways of how can they use a forecast of heat stress in order to be able to minimize the death. I'd make one thing, this is chikungunya, is a disease very close to dengue fever. Over 3,000 people died in Ahmedabad during this period, followed very heavy rains. So this is a disease that's become deadly most recently. So something to watch out for. Chikungunya is now in the Caribbean, I might add. So here's the forecasting heat stress, and the municipal health authorities, they're extremely forward-looking, and they didn't want to use the Indian Meteorological Department forecast, which gives 3 days of smiling suns and weeping clouds. And what they wanted was they wanted to know, should they interact with the society in order to change things. And so they came up with this plan. I don't expect you to read that, but lead times for effective response, hospitals, school children, the elderly, and so on. they could do with lead times. This is enormously forward-looking. And so we went through the usual thing of taking only the Hill-Stillman statement. We don't know if this works particularly much for different nationalities and different clothing and so on. But this is the heat index. This is the temperature the body has to cool from, given the maximum temperature and given the relative humidity. And so the more humid it is, all of you radiation science know that if you're in a very humid environment, your local greenhouse effect, the one that belongs to you, means that you get back radiation very quickly. Those who are into evaporation know that the more humid it is, the less evaporation you get. So therefore, you can see this is the critical region through here, that for a given temperature, you move into very, very critical regions. So this is our little operational product that we give. These are 10-day, 7-day forecasts actually of what occurs during the next 10 days. We do this regularly for them. They seem very happy with that. But the trouble is that this is the amount of the pre-monsoon where the temperatures are hottest, and these are levels. You can see here, these are the apparent temperatures reaching up. This is about a 10-day period, and so we tend to forecast that. But the humidity is very low. So what happens now when we go to Calcutta, where the temperature is lower, but the humidity is high, up to 90–95%, not going below that for 24 hours. Now, we're almost no respite if you're in the extremely hot period, critical temperatures the whole time. We're trying to get mortality data for that, but I'm not quite sure we can. I'm just going to move on to a little bit about the discussion about what works and what doesn't work. So I'll give you some examples of the type of hazard forecasting that one can do. Some of these things may get worse with global warming. Some of them may not get worse. But all we do know is that they're existing right now. Can we do something about it? The heat stress project goes on, but there are a lot of failures too. One of them is that the lack of funding structure. What you would like, I have a friend who's doing drought forecasting in West Africa. And she and her group have been given 1 year as proof of concept that they can do seasonal forecasting of drought. Think of that. That's a funding agency decision, a pragmatic decision based upon no knowledge. Sometimes I think these ideas that we have, I was saying to something, all our failures could be my personality, which can be a little direct at times. But it's seen as foreign interference. If I can tell Bangladesh how to do flood forecasting, it is considered as career damning for those who already do it in Bangladesh. So one tries to do it in terms of cooperation. Inability to transfer technology, inability to handle new technology. We gave computers to Bangladesh to run our system, and they were never run, so we just kept doing it from Georgia Tech. Inability to keep young scientists involved. We used to have 2 workshops a year, and we would go and be 30, 40 people. We'd have them work on modules and all different things. And everybody enthusiastic. Wow, this is terrific. And then you go to the next, 6 months later, another workshop. Room full of eager young people, all of them different. That they'd either been promoted to positions of inconsequence or they'd gone to graduate school somewhere. And it's enormously sad. Yeah, the seniority structure is, if you think it's bad in NOAA, and the ability to obtain data and to be able to use it. Give you an idea of the Bangladesh project. Our first operational forecast I showed you, field assessment, 2009 transfer codes. We continue to do forecast in the absence of Bangladesh takeover. Code transfer to the Shubi Rhymes, which is an NGO. And there's been a steady deterioration of the quality of the output. Each year we have to retune the car engine, so to speak, data changes and so on. So we're still in this valley of death. And how to build a resilient bridge across the valley of death to be useful is, I think, a good PhD project for a sociologist. So, you know, we can build all types of bridges, but most of them don't work very well. So, you know, I think the question I ask, when I started doing this, because I still do regular science tomorrow, I should talk about that, I thought this would be something that everybody would be so happy to receive. And boy, this is great. You can really forecast floods? Ooh, but the funding is a great problem because most funding comes from organizations such as USAID, World Bank, NGOs. They deal with nations. They don't deal with regional solutions. You can't say, look, can you fund something that will do flood forecasting for India, Pakistan, Bangladesh? Can't do it. They have to do interactions. There's a lot of politics in what USAID does. They do some really marvelous things, but there's a political involvement. World Bank, they make loans or they give funds to nations. So it's, and the other thing too is that most of these organizations are not started by scientists, but by people who are skeptical of weather forecasts. No matter, show those red stripe diagrams, it doesn't do much. They're more interested in long-term hazards, global warming, than they are in short-term hazards, even though the short-term hazards that kill people. And also the funding is very short. And there's also the internal thing. So, far more successful has been the interaction we've had with groups like the Gujarat local governments. They want to do something. Very, very cheaply we do it. It's just our time. So it's quite possible. I've pushed the idea that we really have to circumvent government and deal with either the organizations like CARE, Red Cross, local governments, and so on, or come up with some type of mini commercialization, which is in the interests of the people to disseminate forecasts and produce forecasts. There are host problems. Dealing with government entities is difficult at the best of times. Many developing world bureaucracies are very rigid, often battling established structures. India Meteorological Department doesn't talk to the Central Water Authority. The Central Water Authority says, we don't need flood forecasts from you, thank you. We do 2-day forecasts already. And I say, but what about the manatee's cow? And they say, well, but our correlations are 0.8, 0.9. I said, what about the manatee's cow? But it's difficult. So I think also that, and I understand this, that people want to solve their own problems. So I want to talk about regional programs, how it might be better if we can do something like that. RIMES is a 32-member nation, but the trouble is that RIMES is impoverished. It had the floods of Bangkok, which they forecast, by the way, but the dike broke and their mainframe computer was 6 feet underwater. And I remember I almost cried because a friend of mine runs this. I said, oh, your mainframe is gone. He said, no. Once the water goes down and it dries off, it'll be okay. And you know, that's really a numbers sad. So I've got some goals here because we're running short of time. I think that we can do 1 to 15-day lead time of hazards and high impact weather forecasts. I'll give you one little example of this in just a moment. We can do 15 to 30-day outlooks. And we can also do agricultural water resource planning. Our prediction skill is good enough. If you think of it in terms of a probabilistic sense, we're good enough to be able to do that. It's a matter of use. Now here's one of the developing world dilemmas. Biggest problem is incoming bandwidth. Is it possible to develop a routing software? I'll show you about that in a moment. But here's the problem, it's a deluge of data. This is the ECWF data, and she's trying to get a drink out of that. But the trouble is that next year, ECWF says, the model's going to be far better. We're going to double resolution. Uh-oh, that means 4 pipes she has to drink out of. So how can we go from ECWF forecast or NOAA forecast, it doesn't matter, get the type of data that she wants to be able to do that forecast where somebody is watching this particular region looking for hazards rather than me saying in a paper quite cutely, were the Pakistan floods predictable? So that's what we want to be able to do. The ways you can do that, and that is an international routing system where there's a global forecast and the forecast is siphoned off to be able to do specific forecasts in specific regions. I think this is quite possible. The other one is, which I'm very keen on, is global alert system of high impact system or for what you want to do. I'll give you an example of this in a moment. Is where you say 10 days in advance, 9 days, 8 days, you have a map for each day, which shows the probability of exceedance of whatever it might be by 1 standard deviation, 2 standard deviation, be it rainfall, be it tropical cyclones, be what it is. So you have a map of that. And people could go to Google and be able to say, we have a high probability of incidence in a particular region, of a particular hazard. And we've done that. Takes a bit of fooling around with. This is my divided turbo, my colleagues' work. And you finish up with this type of thing. This is 6 days in advance, 5 days in advance of those June rainfalls in northwest India I showed you earlier on. And so this is the type of map you will get. And so rather than somebody having to just look at a particular place, there will be a global map of hazards. This is quite possible to do. So, some conclusions. I think modern ensemble forecasts provide sufficiently long lead times to give useful forecasts of hazards. Trouble is making these forecasts available when they're most used. Too much data, overtaxing the computer system, and so on. It's just a cyber conduit, if you like, that routes data to what is needed. Countries may monitor this global system, or they may not. But it seems to me that if you live in a country where internationally it's known a high probability of floods going to occur, and you and your nation choose not to look or ignore it, then many, many people in that country will. And so I think this is sort of dragging the Indian meteorological departments of the world up by their bootstraps. Anyhow, I think this could be useful. Thank you very much.
Questions for Professor Webster?
Yeah, is there some, like currently I don't have to have powerful computer tool for forecast, I just look at my smartphone. Is there a smartphone, like for example, I was like in Ural Mountains last summer, very big wilderness, and there was still cellular signal there. And so is there some kind of way to use
yes, that's a good idea. One of the great things about India and Bangladesh, I go to Texas and I look at my number of bars I have in my phone that are not. Nothing to do with Texas, it could be Kansas. But, and so our communication system compared to India and Bangladesh, I've never been in one place in India where I haven't had 5 bars, because they have invested in towers. It's cheap. Putting wires up is very expensive, and they get washed away. So that's been very good. So the second thing is, if we put forecasts on cell phones, it's fine. That's how we transmitted our information in Bangladesh. But people have to know how to use that. Now, one thing is that at the end of the cell phone, somebody with a smartphone can disseminate the knowledge for profit, and therefore can disseminate the forecasts. And I don't know. The other way to do it, of course, is if you have television is prepared to put up these high impact forecasts on television. I don't know. But no, cell phones are great, but not everybody has a smartphone. Most people in Bhutan, for example, we have a project in Bhutan. Most of them have a cell phone of some type.
But local government, I'm sure they have cell phones.
Yeah. I know, but
those applications are free that actually show you forecast.
But
Don't have
I'm
to
just
pay
saying
for
that you need a, don't you, for to be able to get pictures, you need one of these. As distinct from one of those old types with no pictures and stuff. As long as somebody can access one of these, that's fine. Yeah, that's good.
Great. Do you still have a question? Yeah, please go ahead.
Okay. Yeah. So based on what you are, what your talk, actually a lot of time it seems that the medium range forecast is actually most important to this depot. So it's interesting because actually for WMO, for example, WRP, SoMAS used to be the program that's supposed to promote medium range, and I think the new projects that's now coming up are either subseasonal to seasonal, which is longer range, or high weather. Now they want to actually focus on the first day or so. So in certain sense, then those may not be as useful to the people.
I think it's a very good question. The question is that concentrations are now in the longer term and the short term. Do they help the members of cow? And I think you're quite right. I think that where we've advanced so much is in the medium range over the last 10 years. ECWF, the work of Tim Palmer and his colleagues have allowed us to be in a place where we can work out the probability of a hazard occurring with sufficient time to be able to do something useful. WMO, not my favorite organization, I'll tell you why. They're in charge of designating the various areas of responsibility for tropical cyclone forecasting. India has the Northern Indian Ocean. They do 3-day forecasts, deterministic, and they don't do the forecast until the vortex has been observed from space, which means that you have probably 2 days warning at best. And so, unless you're lucky enough to have a formation down off the coast of Sumatra or something like that. We've gone to conferences and we've argued that, look, you can do a lot better than this. And if India won't do it, then WMO, why are you underlining that type of activity? So no, they're very difficult to work with because it's like USAID and the World Bank, they deal with nations. They don't deal with the phenomenology. And I think we have to get a big different attitude to the way we deal with things.
Marvin had a question.
Yeah, I'm just curious, Peter, to what extent have you tried UNEP and also the ICSU regional offices? Because experience I had in the Montreal Protocol was such as it is, the top scientists in the country have influence in their government, even if they don't have a lot of influence in the world's scientific bureaucracy. So getting them on board seems to be particularly crucial.
You could be right. And no, I haven't. Just a finite time and it's an hour and a half store.
Yeah.
So, Don,
Yeah, I think you mentioned several times that you give a presentation in a church. I wonder, things like that, group like a World Vision, it's probably ideal for this case. They have people in all the field, and they help you to find cow pretty well. And they're highly educated people. I wonder if you can get through that. That seems to be kind of meet their objective.
I think you're right. The trouble is these people are in the wrong country. The trouble comes down to dealing with heavy bureaucracy. And I think dealing with people with specific problems like the Ahmedabad medical group, they know what they want. They have a vision. I just heard good news that with a bit of luck, the governor of the state of Gujarat may become the next prime minister, which is make it something going in India. I think in terms of getting funding to do that, the developed country humanitarian groups is fine, but getting funding, even though I mentioned that as one of the major problems, one still has to implement. One still has to tell, or inform, I should say, a government institution that you were expecting floods in a certain location at a certain time. And are they receptive to that? I don't know. And that's a difficult thing.
So Steve, you have a question?
Yeah, I just, an observation. You come from Atlanta, and which is allegedly part of the developed world, and you've recently, your point about sort of the availability of information, but then the translating that into what people do. And you've recently suffered in Atlanta from a situation where people knew better but didn't do better in terms of a well-forecast ice event, 2 of them. The second one, the do better, was better than the first one. So can you comment perhaps on the inability of people to deal with information even when they have it, but also perhaps the downside of false positives or false negatives in the information that you give to people?
Well, yeah, that's the one hears about false positive, false negative. Governor Deal, I said, yeah, you know, you can be critical, but what happens if we'd been wrong? If we closed the city down and we'd been wrong? And so what would have happened? There would have been many millions of dollars lost. As it was, there were tens of millions of dollars lost. We had kids in school buses frozen on the highways for 24 hours because silly actions would. They did not look at probability. They received forecasts which are not saying that the probability, and NOAA gives you probability forecasts, but they were looking at the yes/no of an event. What happens if it comes at 4 o'clock or doesn't come? So no, I can defend my Atlanta colleagues, not colleagues, my fellow citizens, by saying it was a very deep 2 inches of snow. The problem was, by the way, it fell and melted and then it froze. And the way I was telling something earlier on that, the way that a southerner takes care of ice and snow is you put your foot to the floor.
Brian?
Yeah, just to follow up on the probability, because I'm relating that Atlanta example to Pakistan or others. I mean, there's a certain probability in which people take action, and because there's a cost involved. And so for Atlanta, you know, there has to be likely a very high probability to take action, because there's that probability times the damage and whether that exceeds the cost.
Yeah.
But in a developing world, the cost of preparedness is, I'm guessing, much less, and therefore you can actually make a forecast which, with a much less probability, 20 or 30%, it's still useful information. So is that the difference between the kind of developing and world and, you know, and us,
yeah.
Where we have to actually have very high probabilities because of this cost of and risk?
No, I think you did right. I use the example of West Peachtree Road, which is a 4-lane surface road, and every time you cross that, you work out risk, probability of being hit by a car. What's the cost of being hit by a car is very, very large. So what you want to do is reduce the probability when you can wait till midnight and then cross the road. With the third world example, yes, but one has to be a little careful. On the one hand, if there is an unanticipated flood, people lose everything. If it turns out to be a false negative, then they have minimal yield. But at the same time, if it turns out to be a good forecast, they save what little crops they can. They save all their farming implements. They save their cows. So the downside potential for the third world is so horrific. I think the thing that has amazed me is how understanding people living on the edge are of probability and understanding risk. More so, I think we're a mollycoddle society in the sense that, you know, we're immune to risk. There's no insurance you can buy on a car, but you can buy insurance on your car.
Your house, Marco?
How do different societies value human life? If you look at the United States, it's all over the place. If you look at the Army Corps of Engineers, they don't put a value on human life, maybe because it's the military. You know, EPA may put it at $1 million, Department of Transportation might put it at $3 million. What about the developing country? I mean, is that related to some of the things you're talking about?
I think so. I'm not a sociologist at all, God forbid, but I think there's still the attitude of, well, born to suffer. I think there's an expectation that certain people, there's a self-expectation that they will suffer. And I think probably, and I say this guardedly, that there are a lot of very, very concerned people in the developing world, but maybe a lot of them just accept that other people are going to suffer. I don't know.
Professor Webster is going to meet with graduate students in half an hour at 1:45 in the Okubo room. So I urge you to go there and ask him questions about this or about tropical meteorology or the monsoons. So let us thank him for such an inspiring